Hello everybody and welcome to my video on descriptive measures. Part 1 we will cover measures of centrality, and in part 2 we will cover measures of spread. So part 1, measures of centrality. So in this case the author did talk about measures of center of a distribution. I am not so much concerned with you manually computing these. I do have another video on how to use technology to compute the measures of centrality. But the first one that the author talks about is the mean, or the sample mean. And let's just note that the sample mean is denoted on the left here by this x bar. So this x bar is how we denote the sample mean, and it says to take the data values, so we denote data values by x, and it says to add them up. So this capital Greek letter sigma is the symbol that we use to interpret this to mean add them up. And then down here in the denominator we divide by a little n. So little n is always considered to be the sample size. So the mean is probably something you've seen and worked with before, and that's about all I want to go into with this one. The next one would be the median. The sample median denotes where the middle of a list of numbers occurs. So the first thing that we would do is to sort the data going from left to right, all right, from smallest to largest, that is, and then we will come over here and go to the n+1 over 2 location. So the median is basically a sample measure that is based on location, and there's no arithmetic involved. So we take the number of data that we have, that's what this n represents, the sample size, add 1, and divide that by 2. So let's take a look at a quick example. So here we can easily see that I have this data set, and there are 24 pieces of data if you were to count them out. So if we take 24 plus 1, we get 25, and now we divide that by 2, and that gives us 12.5. So now what we do, since we have this something 0.5, we always go to the smallest and then to the next one up. So since we have 12.5, that means we would go to the 12th and the 13th location, and we would average those two together. So the 12th and the 13th location is right here, and we can easily see that halfway between 21 and 22 is 21.5. All right, and we can also notice that 12 pieces of data lie from this part all the way down to here. And then on the upper side, we have half the data set going all the way up to here, and notice that the median is right in the middle at 21.5. All right, so again, I'm not interested in you manually computing these things, but I would like for you to use technology and just note that the median is the center of the location, and to recall that the median is a center based on where the actual center is, and it's based on location. And finally, the last one is the mode, and let's just note that the mode is the most frequent data value or data values that occur. If you have 2 or 3 that occur the same amount of time, then we have more than one mode, and that the mode is also used with categorical data or qualitative data as well. So in this case, we have some non-numeric data based on political preferences. And here, if we take a look-see and you were to go through and count up the number of Republicans, Democrats, and others, you will find out that Democrat occurs most frequently. And coming back to our familiar example here, let's just note that if we were to come through here, let's just notice that we have, what do we have here? 1, 2, 3, there's 4 19s. All right, and then there's 1, 2, 3, 4, 5 20s, 2 21s, and then 1, 2, 3, 4 22s. So far 20 has got it at 5, and then a couple of 24s, a 25, couple 26s. So we can easily see here that the mode in this case would be 20. Now if we got rid of one of these 20s, then we can see we have 4 19s, then we would have 4 20s if we got rid of one, and then we would have 4 22s. So that would mean that 19, 20, and 22 would be the mode, again under the assumption we get rid of one of these 20s. Okay, so just to quickly review our measures of centrality. Our measures of centrality then is the mean, which is just taking and adding up the data and dividing by the number of data that we have. The next one is the median, which is found by taking a data set, sorting it, and then going to the middle location. And then finally, the mode is when we take a look-see at which data value or data values that occurs most frequent. And it's interesting to note that the only one that involves any arithmetic is the sample mean. Notice that the median is by location and the mode is by frequency. Part 2 are measures of spread. So in our measures of spread, that is, how does the data spread about its mean? So the mean doesn't always tell the whole story, but we need to know how is the data spread about the center of the distribution. So in this case, the author did mention 3 measures that he talked about, and the first would be one of them being the sample variance, another being the sample range or the range, and the other one being the sample standard deviation. So by far the sample range or the range itself is the most easiest to compute. As we can see here, it's just taking the maximum minus the minimum. So notice here the maximum is 43 and the minimum is 18. So when I take the difference of 43 and 18, I end up with 25. So this kind of tells us kind of down and dirty just kind of what the spread of the data set is in its whole entirety. The next one would be the sample variance, and I just want to note that the sample variance is denoted by S squared. Okay, and basically this formula is kind of a bit of a doozy of a formula, but here it says to take the data, subtract its mean. Okay, so this tells us how far away a data lies from its mean, and then we're going to square those. So we first compute the distance that a data value lies from its mean. We square those distances, we add up those squared distances, and then here we divide by n minus 1. All right, so let's just take a peek-see real quick at this thing in action and kind of talk through what's going on here. But again, this one, I'm not interested in you doing this by hand. I am interested in you to compute the sample variance using technology, StatCrunch in particular, and then interpreting your results. And there is a difference between the sample variance, which is what I'm pointing out here, the sample variance, and the population variance. And in the video where I show you how to compute these, we discuss those. So let's just note that our variance, to compute the variance, if we had to do this by hand, I have 8 pieces of data from my summer 2018 class. And if you compute the mean of these 18, we come up with a sample mean, or x bar, of 24.8 years. So here is the data set in this column here. And let's just note that the units is in years. So this says to take the data value and subtract its mean. So notice if I take 30 minus 24.8, that gives me 5.2. If I take 26 and subtract 24.8, it gives me 1.2. And if I take 19 and subtract 24.8, I get a negative 5.8. So notice that these differences right here, when they're positive, tell us that the data value is larger than its mean. And when I take a look at the negatives, then the negatives means that the data value is smaller than its mean. All right, so then if I take 5.2 and square, it gives me 27.04. If I take 1.2 squared, it gives me 1.44. And if I take negative 5.8 and square it, that gives me 33.64. So these are all the squared values. Here are the squared distances that the data lies from its mean. So let's just note that the units here right now this is in years right here. And let's just note that this one here is in years. And then notice that when I square those, I get years squared. And let's just observe that this total right here is the sum. So just flipping back real quick, notice that that first column was our age, our middle column was this, and then the third column was this squared, and then that bottom number at 162 was the sum. Okay, So this sum is 162.92. So now what we do is we take 162.92, divide that by 7, and notice that that gives me 23.3. Again, let's just observe that this is in years. When I take 30 years, subtract that from 24.8, I get 5.2 years. But when I take 5.2 years and square it, it gives me 27.04 years squared here and years squared here. And when I add them up, I get years squared. And notice that I have 162.92 years squared. And this denominator is 8 minus 1, which is 7. There's no units associated. So I end up with 23.3 years squared. So let's just observe that the variance tells us the average squared distance that the data lies from the mean. So let me repeat that one more time. When I go to compute 23.3, that tells me the average squared distance that the data lies from its mean. Now, the sample standard deviation is found by taking the square root of the variance. So if I take the square root of 23.3 years squared, let's just note that gives me 4.8 years. So the standard deviation is actually related to the variance in that if you know the standard deviation and if you square the standard deviation, that will give you the variance, and vice versa. If I gave you a variance of 100 and asked you for the standard deviation, you take the square root of 100, it gives you 10. All right, so you know one, you square it, gives you the other one. It's basically the bottom line here. All right, so let's just note that the standard deviation is 4.8 years. So what this tells me is the average distance that the data lies from its mean. The variance tells me the average squared distance that the data lies from the mean. The standard deviation tells me the average distance that the data lies from its mean. So the idea is that the smaller the standard deviation, the more clustered about the mean that the data would lie, and the more larger that the standard deviation is, then the more spread out the data is from its mean. So that is how we work with measures of spread, and in my next video we will talk about how the median works with another measure called the IQR, or the interquartile range. So we have the standard, we'll see in a little bit that the mean and the standard deviation work together, and then later under certain circumstances that the median along with what's called the IQR tend to work together hand in hand. And in conclusion, I would just like to state that there is a relationship between the mean, median, and mode and the shape of the distribution. Let's just come down here to the bottom part. If our shape is a bell-shaped distribution, and under a perfect world and under a perfect paradigm, that would mean that the mean, median, and mode would be exactly the same. But we don't always live in a perfect realm, but these would be approximate. So let's just come over here to the upper left where I have this skewed right distribution. Again, notice that the skewness is determined by where the elongated tail is. So the bulk of the data lies here, and then we have some scragglers out over here. And let's just notice that because of these scragglers, that will tend to have an effect when you perform arithmetic operations. So again, if we're down here and I was taking a look at your average annual salary and I was asking everybody in the classroom how much they made or filing for their taxes, and then we had like Bill Gates and Jeff Bezos and a few other people, that would tend to inflate this mean. But because the median is based on location, this is a way to downplay the mean. So when you have a skewed data and the same argument over here for the left skewed, all right, so we're over here and I have a bunch of A's and B's over here on an exam, but then I get a bunch of D's and F's, or people who didn't even take the exam, we can see that that tends to deflate the mean. All right, but the median is robust, is what we say, is robust against departures. So whether we have extremely small values or extremely large values. So the median is less affected by these. And at the top of the hump, just to kind of put some closure, at the top of the hump, this is where the mode is. So notice that the mode would be right here, and at the top of the hump, which is the most frequent over here, is the mode. So you can kind of get an idea about how the skewness will have an effect on these. And this is why it's always important to draw a graph and get an idea of what the distribution of the data is before you start putting out numerical summaries. All right, that concludes my video right now for discussing measures of centrality and measures of spread.